Hello there, I'm Mr. Math Guy, and today we're going to be taking a look at a 10-minute video on Intro to Integrals. There are many different uses for integrals. The one that we're going to be focusing on mostly in this video is to help us to find the area under the curve of a function. When we talk about integrals, we talk about, another word is we use is integration. And we can use integration to find other things, areas, volumes, central points, other useful things in the field of mathematics. But for this video, we're going to mostly focus on the notation and what integrals mean for us as far as finding the area underneath the curve. So let's take a look at here at an example. First of all, maybe some understanding of some notation. The integral symbol it's kind of like a stylish S, and it stands for the summation or the summing up of parts. All right, so summation. So I'm gonna put it right here, kind of like a stylish S, summation. The part that comes after, on the kind of the top and the bottom of the summation symbol, those are your values for which you're looking underneath the curve. So we're going to be looking underneath the curve from 1 to 3. This part right here, that is the function that you're looking at, and it's called the integrand sometimes. And then we finish with this little dx. That just simply means that it's going in the x direction, our width. So it's going in the x direction. So what this means then is simply this. If we have a curve, or the function, negative 2x plus 7. So let's draw that. So here is our function. F of x is equal to negative 2x plus 7. It's just a linear function, it's a line. Now, the part that we want to be focused upon, the area underneath of this function from the values from 1 to 3. So from right here at 1, so everything under here, so from here all the way to 3. Now you go over 1, 2, 3, and it's right there. So we just want to take a look at the area underneath this curve in that box that I have right there, or that it appears to be a trapezoid. So I'm trying to find the area of this shaded portion. All right. Now, that's what integrals will help us do. It's the summation of all the parts. As we've learned in previous videos, we've learned to approximate by breaking this up into different subintervals and getting the area of rectangles, base times height, adding those together, and it gives us an approximate answer. So the area that this integral represents, I wrote it down here for you, is the area under the graph f of x equals negative 2x plus 7 from 1 to 3, and also knowing that we are stopping it here at the x-axis. Now, this would be a picture of the graph of what we're looking at. Now, to be able to figure out the area using a graphing calculator, I'm using the TI-83 Plus. What we would do is we would go to our math button, and then we would go down to, in mine it's number 9, and this shows up when you push enter. And then we type in the function, so negative 2x plus 7, and then we use a comma, x-axis, comma, 1, comma, 3, because that's the width of this, from 1 to 3, and then put a parentheses, and then hit enter. Now, on different calculators, it's going to vary a little bit on how you plug in things, but this is how it works on the TI-83 Plus. and then you get the area is 6 on your graphing utility. Now, we can check this one with a geometry formula that we know, because the area of a trapezoid we know is 1/2 h times the sum of the bases. And we could figure this one out, because the height of this this trapezoid is 1, 2, 3, 4, 5. The height of it is 5. Now, the base, one base is going to be 5, or 1, 2, 3, 4, 5, 6. So it's 6, and I messed up on the height there. I'll come back to that. And the other one, the height of it is just from here to here, so it's 1. Now, going back to this height, excuse me, the height is going to be the width of the interval, so it's going to be from 1, 2, 3, because the bases have to be the parallel sides. So there's the basis, and this will be the height. So this is going to be 2. Now, if we take 6 plus 1, we get 7. And if we multiply 7 by 2, we get 14. And if we take half of 14, we get 7. And you say, well, I thought that was supposed to be 6. And you're right, because I just realized another mistake. Sorry, can't count tonight. This height, or this base, is 1, 2, 3, 4, 5. It's only 5. So 5 plus 1 is 6. 6 times 2 is 12. And half of 12 is 6. So we have here, by using geometry formula, we know our area is 6. In the red down here, we used our graphing utility, or graphing calculator, and we're able to find the area underneath the curve using the integral function key on our calculator. So that's what we're going to try to work on here, just using our calculator a little bit and understanding what this integral even means for us in this video. So if we take a look at another example, the integral here, the function is 16 minus x squared. We're looking at the range from 0 to 4, the interval from 0 to 4 in the x direction. So first of all, we could graph this. So the y-intercept is 16. It's a parabola that goes downward. Just kind of sketched it really quick. Each of these intervals represents 2. So the area that we're looking at is from 0 to 4. So from here all the way over to here, it does intercept at exactly 4, 0. So we're looking at all of this area here. This is the area that we're trying to figure out. So this integral represents the area under the curve 16 minus x squared from 0 to 4, all of this. Here is the graph. Now, let's use our calculator, or graphing utility, to figure out the area of the underneath the curve. So I go to math, I go to number 9, I punch in 16 minus x squared, comma, x, comma, 0, comma, 4. Again, it might be different on different calculators, but when you do this, you get an area of 42.6 repeating, so it'd be 42 2/3 if you wanted to write it as a fraction. So this would be the area underneath this curve. So in this example, I have a trig function here, the integral, or the summation from negative pi over 4 to pi over 4 of cosine x dx. Now I've already taken the liberty of drawing the cosine curve, and I've taken a look at the area underneath the curve that I want to try to find the area of. It's kind of in yellow. All right, it goes from basically negative pi over 4 to pi over 4, so it's all this. This is almost about 1 there, so it could be 1, and it's almost 2 units long. All right, it's actually closer to 1.5 long, and it's almost 1. So if we just consider this to be a rectangle, we'd think, oh, it's 1 times 1.5, which is 1.5. When we do it on the graphing calculator, we get 1.41 square units. So that makes sense. So this is a lesson on Intro to Integrals, finding the area underneath the curve. God bless.